All right, so our next unit is all about different types of numbers and how we can represent them. And one of those ways is just by classifying types of numbers. So the first type of number that you've probably heard of is a natural number, and that's all the counting numbers. So we start at 1 and we count up by whole numbers. Our next region is called whole numbers, and that is all the natural numbers, but it also includes 0. The next step up includes natural numbers, includes whole numbers, but now we also include negative whole numbers. So integers would be what these are called. So those are negative or positive whole numbers. Finally, we have rational numbers, which is all sorts of numbers, but there are 2 qualifications to be a rational number. You either have to be able to write it as a fraction or as a decimal that repeats. So for example, 7.121212, etc. We use that bar over the top. And then there's numbers that are irrational, and a good example of this is pi, because pi has no pattern. It goes 3.14, etc., and never stops. So irrational numbers are numbers that can't be written as a fraction or they don't repeat. Square root 2 is also a good example, so I encourage you to type in square root 2 and check what happens. So there has to be a way to classify numbers without writing out the whole word. So natural numbers, we use the letter N. Whole numbers, we use W. Integers, we don't use I, but we use Z instead. Okay, so integers will be represented by Z. Rational numbers are R, and irrational numbers are represented by Q. So let's do an example. So negative 3 over 10 says name each type of number and determine whether it's an irrational number. So negative 3 out of 10 is written as a fraction, so it's definitely rational. Okay, so it's rational, so we have R. And it's also a decimal. But again, it's not a whole number of a positive or negative variety. So we would just say this is a rational number. Square root 5, let's use a calculator and find the square root of 5. So square root of 5 gives us this number, 2.23, etc. There's no repeating values, so we would say that square root 5 is an irrational number. Next we have the cube root of 8 over 27. Now I could type that into my calculator, but let's think for a second if there's a number that I can cube to get 8. And the answer is 2. So the cube root of 8 is 2. And the cube root of 27, well, 3 times 3 times 3 gives us 27. So 2/3 is going to be my answer. And 2/3, when you divide on your calculator, you will get 0.666, etc., repeating. So we call this a rational number. Now negative 4, we think, oh, that's an easy number. It's an integer. It is an integer, and it's also a rational number. Okay, so let's try the following. Order the following numbers without a calculator. So negative 3/5, let's write it so it's a little easier to look at. If we multiply by 2, we get negative 6 over 10, which is a nice number because we can write that as negative 0.6 because it's 6/10. Negative 0.65 is okay. Oops. Negative is the square root of 0.5. Now I don't know exactly what that equals, but I know that the square root of 49 is equal to 7, which means the square root of 0.49 is equal to 0.7. So negative 0.5, which I can add a 0 after, negative 0.50 is very close to negative 0.49. So I'm going to say this one is approximately negative 0.71 or 701, but something very close to this. Negative 2/3 we've already done, so hopefully remember it's negative 0.66 repeating. And finally we have negative 17 over 50. And again, I want to make this out of a nice denominator, so I think 100 would be a nice one to do. So we have negative 34 out of 100, which is equal to negative 0.34, because we have 34 hundredths. And now we just have to put them in order from smallest to biggest. So remember, the more negative a number is, the farther away from 0. So we would say that this one is the smallest. Then we have our next smallest, and so on. Right. Next, we have which number system best represents the fourth root of 9? This one's a little difficult. It's hard to find this on your calculator, so let's try to write it as in a different way. So the fourth root of 9, well, I know that I can write this as the fourth root of 3 times 3. That doesn't really help me. So instead, maybe we should write it as, or let's find a perfect fourth that's close by. So I know I have 1 times 1 times 1 times 1, which equals 1. And I have 2 times 2 times 2 times 2, which equals 16. So it's definitely between one of these two. Closer to 16, maybe. So 9 to 16 is 7 spaces versus this is 8. So it's kind of in the middle. So it's going to be 1.55, something of the variety. Okay, because we don't know exactly, we're going to call this a rational number until we can check with our calculator. So on your calculator, to check a fourth root, what you do is you type in the number, and then you raise it to the power of 1 divided by 4. That's how you do a fourth root, is 1 divided by 4. And we get this really gross number, 1.73, no repeating. So instead of rational, we say it is irrational. Okay. So identify each of the following as irrational or rational. So this is a fraction, so we call this rational. Root 14, again, you're going to need your calculator. Square root 14 gives us a number that does not repeat. So irrational. And the cube root of 81. Remember, when you're trying to do the cube root or fourth root, you do the number 81 to the power of, and this time we do 1/3. And again, that is not a nice number. So we are going to say irrational.